Hello and welcome. In this video, we will push a little forward with our understanding of synchronous counters in VHDL. To be specific, we will design a synchronous counter using VHDL, but we'll use a different method from that which was used in the previous method. So in the previous method, we went as we looked at this system, we decided the various states we run through, came up with a structural definition in actually came up with a structural design, and then now define that structurally in VHDL. Now in this video, we will take a different route, and one thing I'll do in this video is I introduce a couple of tools that could possibly help you. So first things first, I've created a project called Sync Counter 2, which is, well, in the folder that I've been working with Sync Counter 2. But I won't work in quarters for this video. At least the bulk of the work will not be done in quarters. I will still do a significant part of work in Model Sim. So let me go ahead and start off Model Sim on my computer. But the program I will actually write in for this particular program, for this particular design, the program I'll write it in Visual Studio Code. And the reason for this is I think you could find this quite useful. Working in Visual Studio Code might, if you're not necessarily creating a quarters project and compiling, if you just want to say all you want to do is this Model Sim, by the way, if all you want to do really is to write the VHDL code and then simulate it in a test bench, then you could write all your code within Model Sim, but it might be easier to do so in Visual Studio Code. So firstly, I've opened up Model Sim, and I'll suggest you do this. When you're working in Model Sim, it has an active directory it is working with. So one thing you could do is to go to File and create a new project. You could create a new project, and that would be a good way to work. Or on the other hand, you could just change your active directory that you're working with. So in this case, I'll change my directory since really I already have a quarters project. I don't want to create a new project in Model Sim. If all I was doing was writing VHDL code and simulating a test bench, yes, it makes sense to create a Model Sim project. In this case, I won't bother doing that. Counters, Sync Counter 2. This is the folder for the project, for the quarters project. I'll select this folder and I'll just wait. Okay, so nothing to simulate just yet. Now I'll open up Visual Studio Code. This is Visual Studio Code. And what I have done is, when you install Visual Studio Code and run it, then you could go to Open Folder. Open Folder, now navigate to the particular folder you're interested in. Sync Counter 2 is the folder I'm interested in, so I select that particular folder, and this shows the files that are in there. I already had the folder open when by the start of this video. This shows the files that are in there. This is a quarters project file, quarters specification file, and then this is a blank VHDL file. Let me double click on this to just show you what's in it. For now, it's an empty VHDL file that I just created. Okay, so I created that file. There's nothing inside of it at present. Then I've gone ahead to take the liberty of creating a test bench, so I don't use our time to create that in this case. I could make this a little larger so you could go through and see what it does. We'll come back to the test bench in a bit. Control plus, Control minus can be used to zoom in or zoom out of the Visual Studio Code environment. Now, when you're in Visual Studio Code, before you do any programming in VHDL, first thing I would suggest, notice it recognizes the syntax, the VHDL syntax. That doesn't happen automatically. What I've done is I've gone to extensions. On the left here, you see extensions. Click on extensions. Search for Vhdl Wiz. So I would recommend Vhdl Wiz particularly. And once you have it in here, I have it installed, so this button says uninstall. However, if you don't have it installed, you will have a button here that says, a green button that says install. So click on it, install it. Once you have it installed in Visual Studio Code, then you could use it. Now, one of the things I like about Vhdl Wiz is the fact that it has a number of snippets. So you could type in some code snippets, and just for instance, by typing ARCH, that would create an architecture environment within your VHDL code. If you scroll down, you have one that says VHDL, and there's VHDL TB. So VHDL is a VHDL template. VHDL TB is a VHDL test bench template. So this is our empty file here. If I just simply type VHDL and I press enter, it's oh, sorry, okay. Is this the one? Yes, okay, so no, this is not actually, so this is another VHDL template I had installed. Another VHDL extension I had installed. So VHDL, it also has a VHDL, yes, so this is the one created by Vhdl Wiz. Okay, so notice it comes with, it does this definition for you. All I did was type VHDL and press enter, and it creates this shell for me. Now, is this exact, are this the particular ports I'm interested in? No, but I could always change this to whatever it is I want. But then it reduces the amount of typing you have to do. If I had done VHDL TB and pressed enter, notice it creates a test bench, creates a number of things, even creates a process in there, so that you just go ahead and fill it up, fill it in, creates, I mean, it's ready for, literally it is ready for you. Okay, it's ready for you to use. So just take note that you could make use of this. You could just make use of this directly. Okay, so I'll go ahead and just use this. The name of the entity I'm working with is sync counter 2. Okay, so sync counter 2 is the name of the project I'm working on. I'll just copy that and paste that down here as well. RTL of that and architecture. Okay, so we have that so far. What are the ports we're interested in? We need a clock bit, and then we also need a queue. But the queue in our case will be an output. And like we did in the last video, this is going to be 2 down to 0. One of the things about working with VS Code, as you can see, let me make this a little larger so it's easier to see, is that it makes it gives you code completion. Okay, so code completion is a possibility. I don't need any other ports. Code completion is a possibility, so you don't have to type everything. You could just easily press tabs and it will walk through. Okay, so in here we're going to need to have a process, and as our sensitivity list of the process, we're going to have CLK. We'll begin, and then well, let me type end straight up so I don't end process, so I don't forget to do this. Okay, so begin again. It does it tabs things for you, puts tabs there to help your writing process. We're going to need an if statement, and we're going to need rising edge. So apparently it does not recognize every single code. It doesn't complete every single code for you, but it is quite good at it. So if rising edge clock, then we're going to have to do something. So let me just simply say q is equal to something. We're going to assign something to q and then end if. So let's now talk about the method I'm going to use. So this is a simple shell of my program. What I'm going to do in this case is I'm going to define a signal. I'm going to define a signal that is s_q. I'll make it of type unsigned. Okay, so unsigned integer. I'll make it an unsigned integer. Well, an unsigned integer. Okay, and then I'll initialize it to 0. Now I need to come back here and mention the fact that I didn't talk about the fact that IEEE.numeric standard is here. So usually we've used, in all our videos so far, we've used the standard logic 1164.all, but there's also the numeric standard that in many cases we will also use, but so far we haven't used. Now if I bring in a numeric standard, then we have a type called unsigned. And I'm using unsigned in this case because it is convenient to use. So I'll take this out here and place this down here, okay, and simply assign s_q to q. Now in here, whenever there's a rising edge of clock, all I'm going to say is that my s_q, I'm going to assign s_q plus 1, and that's that. Okay, so that is that simply. I believe I need to specify this 2 down to 0. Okay, so unsigned is an unsigned integer, but then it's of type. It's similar to standard logic. Yeah, so it's similar to standard logic, but here we are specifying that we are not using the signed bit. The MSB is definitely not a signed bit. With standard logic, we are not specifying whether or not the MSB is a signed bit or not. We just simply have it. There as standard logic. We have a certain number of bits. In this case, 3 bits. Here we are specifying that we have 3 bits. The MSB is not a signed bit. So that's what this particular variable specifies for us. Now I could just simply tell it to do this. Because it's already a 3-bit vector, we know it will cycle through the normal process like we're used to. And this is my complete definition of the counter. I've not specified anything else other than saying whenever there's a rising edge of clock, go ahead to do this. By the way, I haven't done this before, but then we could say whenever there's a falling edge of clock, so it doesn't have to be rising edge. If we're using negative going transitions, then we could say falling edge of clock. But let me leave it as rising, so it's exactly similar to our previous video. Now, if we look at the test bench, in our test bench, I brought in the component CLK and Q, sync counter 2, and simply did a port mapping over here. Now, one thing I should correct, in the previous video, I mentioned the fact that model sim does not like when we do work dot this and then put in the particular architecture. It apparently can work with this, but there's a command I need. I need to use entity here. If I place entity in front of it, then it's happy to receive this. So I'll leave this in here and let's see how model sim does. So we're done with our counter, we're done with our test bench. Let's go ahead and open up model sim. So this is model sim. I changed my working directory to sync counter.2. Okay, so we're fine with that. Now I can just go ahead and hit compile, hit the compile button. It shows me the files that are inside this folder. So sync counter2, compile that. Work does not exist. Do I want it to create it? Yes, please. So because I have not compiled inside this folder, it's a brand new folder, the work library does not exist. So go ahead and compile this. So it compiles it, it finds 2 errors, it's complaining about something. I left something out. Oh, yes, I did. I forgot to do something. Now, this SQ, where you? No, that's okay. So the SQ inside my entity, SQ is of type unsigned, okay, is of type unsigned. So let me go back to model sim. I didn't specify what the error it complained about was. Now, if you take a look at the error here says that index constraint not applied to non-array type. It's looking at, did it specify the, so it talks about line 8 and line 9 of the VHDL code. So let's go into VS Code, line 8 and line 9. So you have this over here, standard logic, and then the fact that this is oh yes, so sorry about that. A semicolon was included there that should not have been included. That's what it's complaining about. However, there will be a problem with this code, and that is based on the fact that SQ is unsigned. And after incrementing it and doing whatever we did with SQ, we just assigned unsigned automatically to standard logic. Now, you can't just tell it to write unsigned as standard logic. That will most likely throw an error. So instead, I'm going to specify standard logic vector to tell the compiler that it should take SQ and cast it as standard logic vector. Whatever is in here, cast it as standard logic vector and take it in there. This command will convert unsigned or signed, as the case may be, to standard logic vector. So now we should be fine. Let's get back to model sim. One other thing I will mention about model sim, I mentioned earlier on that you have this command, okay, that you have this command you can as well type, so that instead of hitting the command button, instead of hitting button, clicking, you can just type in commands. Now what I'm going to do is I'll copy this command as is and paste it in here, press enter, and it goes ahead and compiles the same file. Note it does exactly the same thing. Now this time it complained about an error. It said non-array type. Oh, sorry, did I type something wrong? Oh, yes, I did. I wrote it as standard logic, whereas it is standard logic vector, and that's why it's complaining the array. I'm trying to cast a non-array type, so the index constraint cannot be used for a non-array type. Okay, so an array type is a standard logic vector. That's an array type. Standard logic is not an array type, so we cannot give it an index. Okay, so this should be fine now. Let's go ahead and up arrow key, enter. Now it's complaining about, oh, did I do something? This line 13, when I initialized. Yes, I did. This should not be initialization. That should be an assignment. So sorry about that, or that should be a definition rather of the type. Now, one issue is integer literal 0 is not of type. That is correct. I used an integer literal here, whereas it's supposed to be an array. Okay, so 0, 0, 0, or others, like I often do. So this should be fine now. Model sim up, and now it goes through with no errors in there. I can just do up arrow key and change this from this to test bench, which is the other VHDL file I want to compile, and voila, it has compiled that. Now I have a work library. I have my sync counter with architecture RTL. I have my test bench. I could right click on this and simulate. So again, I could have typed vsim and all of that, and it's pulling out the, so it starts my simulator. I can create waves or add waves to this. I could tell it, specify I want this to be, say 100 nanoseconds, and I could run this. So I go ahead and run this. It has run for 100 nanoseconds. I say zoom full, and it shows it has run. Let's pop this out so that maybe we can see it a little better if it doesn't go hiding on us. Okay, so where is my simulator? It's on the other screen. There you are, or the waveform rather, I should say. So it's on. Now we see this. Let's again make this full. We can zoom in, or I could change the radix of this just so that you see it in unsigned. Now you see 0, 1, 2, 3, 4, 5, 6, 7. It just like we expect it to do. So it functions perfectly well. Okay, so this is cool. This is working as it should. I'll end this simulation. And what I want to do next is to go into Quarters. The reason why I created a project in Quarters in the first place, I did not need to create it really. But the reason why I created a project in Quarters was I wanted to, okay, so I double clicked on this largely because I want to be sure that it has found the sync counter to the Vhdl, because I didn't compile this in Quarters. Okay, so now I'll compile this in Quarters. Yeah, like I'm compiling a second time. Reason why I'm doing this is because I want to look at the netlist viewer. I want to look at the RTL viewer, and that's the entire reason why I created a Quarters project and specified it to our particular FPGA. I want it to create a circuitry so we see what the circuitry actually does look like when we write our code in that way. We know what the circuitry looked like when we specified that we wanted a particular structure. It created that structure for us, and that worked perfectly well. While this is compiling, let's see if I can open up the project we had in the last class. So I'll open up another, in the last video, I'll open up another Quarters environment, and the aim will be to load up the sync counter 1, the structural definition that we had. Okay, so like as we see here, we are not expecting any error because, I mean, we already compiled it in Model Sim and it worked fine. So I'll open up the netlist viewer, RTL viewer in Quarters. And this is what it looks like. Okay, so apparently this is all that it did. They just simply took the output and they had an addition over here. And apparently this works. Now you notice that this here, SQ2 down to 0 is what they wrote here, and same thing for this signal. So this signal is not a single D flip-flop. It is actually 3 flip-flops put together. But then this is the simple, if I double click on this, okay, I can't go any lower than that. Okay, so you have an SQ0, SQ1, and SQ2. So that shows that you actually have 3 registers there, not just a single D flip-flop. I'll close this and come back here. Now notice total number of logic elements, 3. Okay, so that's for my sync counter 2. Now let me pull up the sync counter 1 project. This is the sync counter 1 project we had in the last video. I want to see view reports. To view the report, it could most likely compile this again. So just give a few moments, it could compile this, and what we want to do is we want to compare the compilation reports from sync counter 1, where we specified the architecture, to that in sync counter 2, where we didn't quite specify the architecture, but we let it come up with the most optimal solution. Now notice total number of logic elements when we did the structural definition is 12. Total number of registers, 3. Total number of pins, 10. Okay. Now back to sync counter 2. Total number of logic elements, 3. Total number of registers, 3. Total number of pins, 4. Well, in fairness, maybe this is not exactly an apples to apples comparison, because sync counter 1, if you remember well, we had we also included set and reset. Okay, we also included set and reset. We don't have that in these here. So maybe we should modify this code to be able to compare them together. But you will realize that apparently Vhdl and Quarters seem to do a much better job than we did when we did our structural definition. So I'll come back to VS Code, and in here, next thing I'll do is maybe at this point, permit me to just pause and mention that I talked about this extension by Vhdl Wiz. There's a video I would recommend. I'll put a link to this in the description, and this is Vhdl Wiz talking about this particular extension he has for VS Code, and he talks about the various snippets that you can use in there. So I'll recommend that you watch this video. He will talk about the various snippets. He also has a snippet that he has for if you want to, when you want to run your simulation in Model Sim. You can actually use a snippet that you had to specify various parameters you want to run, so that in Model Sim, basically you just type one command, run.do, and it just simply don't do run.do, and it simply runs the entire simulation as you want it to run the simulation. So I recommend this video. I'll put the link to this in the description. Okay, so back to this definition. What I did was I defined this as an unsigned array. So let me change this, and what I'm going to do is define this differently. What if instead of defining it as an unsigned vector, what I'm going to do is define it as an integer. SQ, define SQ as an integer. So define it as an integer. When you're defining an integer, you need to specify the range. Range 0 to 7. Now, why is it important to define the range? Now, because it's an integer, I can initialize it to 0 using that. Why is it necessary to define the range? When you define the range, you're telling VHDL the number of bits to reserve. So, for example, if I had said 0 to 70, 0 to 70 means that I need at least 7 bits. To register 0 to 70, I need to have at least 7 bits. If I say 0 to 8, I need at least 4 bits. 0 to 7 means 3 bits. 0 to 8 means 4 bits. So you could reserve 4 bits for you. So 0 to 7 is what I'm specifying in this case. In other words, 3 bits. Now if I compile this, I will run into an error. Okay, it will give me an error. Let's see. Do I still have the code in here? Yes, I still have it here. If I run it, it gives me some errors, and it tells me, okay, so the first error it's giving me is the fact that I'm trying to do an illegal conversion. That is over here. Let's just confirm that. Line 22, yes. So line 22 is telling me I'm trying to do an illegal conversion. That is correct. So firstly, I'll comment this out just so that I keep both files I make, so you see, you can compare them. And what I'm going to do is, first of all, I'll convert to, okay, so let me copy some part of this code, because I'll use some part of the code. I'm going to first of all convert it to unsigned. Okay, so I first convert to unsigned, and then I'll make it standard logic vector. So first of all, I converted the integer to unsigned. There's a command for doing that, and then I now cast it as standard logic vector. So now it shouldn't pull up that error anymore, but there is another error I'm expecting it to pull up. Yep. So okay, it says to unsigned, no feasible entries for to unsigned. Why is that? That is line 23. Why are you complaining about line 23? We use numeric standard, that is correct. To unsigned is supposed to work. Why are you not working? Oh, sorry. To unsigned, I need to specify the number of bits. Remember, unsigned is a vector, so I need to specify the number of bits I have in that vector. So now this should be fine. Okay, so it runs through. And apparently it runs through with no errors. Okay, so it runs through with no errors, but I'm claiming there will still be an error somewhere. So let's come here and compile the test bench again. I don't need to change anything in the test bench, because really test bench is agnostic to the particular entity itself. As long as the ports remain the same, then that's perfectly fine. Again, I'll simulate this for a bunch of nanoseconds. Run. So it simulates this, and notice this stops at 30 nanoseconds. If you don't notice anything else on the screen, there's something else on the screen you should take note of. But in case you don't notice that, this is stopping at 30 nanoseconds, but we told you to run for 100 nanoseconds. Come down to this point, you see fatal error in process at line 16, and it says that sync counter line 19. It's having a problem with line 19 in sync counter. Does it specify what the issue is? So, okay, yes, fatal. vsim value 8 is out of range 0 to 7. Okay, so it was trying to write value 8, but that is out of the range of 0 to 7. Let's come back to VS Code. Now, what was happening in the line 19? This is what is complained about. What was going on is it was incrementing the value and everything was fine. Around the time when it got to 30 nanoseconds, you would try to add, tried to add 1 to the value of SQ. But SQ says range 0 to 7. And then suddenly adding 1 is outside that range. And so that creates a problem. Okay, that creates a problem. It cannot add 1 to it. So what can we do? How can we fix this? What we're going to do is that we're going to check the value of s underscore q at every point in time. Now, when s underscore q is less than 7, then we can go ahead and do this. Else, in other words, if okay, then let me have my end if, just end if, so I don't forget to include that. Else, if SQ is not less than 7. If it's not less than 7, then it means it is 7 or above. Then we want to make SQ roll back to 0. Okay, we want to make SQ go back to 0. Now, this is because this is an integer. It is not an unsigned vector. The unsigned vector has 3 bits. Add 1 to it, by default, it goes to 0. But for integers, once you add 1 to them, they try to go above that. That is the definition for them in the IEEE numeric standard.org. That's the way they are defined in there. So we go ahead and now try to, let's compile this once again. Again, it should compile with no errors. I'll end the simulation. End simulation, yes please. And then let's go ahead and compile this, compile that, and then compile the test bench again. Okay, no errors. Then let's go ahead and launch the simulation. Yep, simulate this, please. Okay, let's simulate that. Then we need to add this to, I used the wrong command delete earlier. So add those two. Again, I want to specify I'm doing this for n. Again, we could just automate all of these specifications. I keep on having to do one by one, adding the okay, so it has done simulation. Now notice that it ran for 100 nanoseconds this time without a problem, and this is exactly what we had before. We could pop this out, or we could just zoom in and see that it is now, after when it gets to 111, it cycles back to 000 and it keeps going. It gets to 111 again and cycles back to 000. So it's now working like we expect it to work. Okay, so now it's working like we expect it to work, and it's perfectly fine. So take note that if you're going to use an integer to increment a counter, you might need to specify some things. So it seems like it's a good idea to always use unsigned, an unsigned vector. That is partly true, but that's not entirely true. So yes, it's good to use unsigned. However, there are cases where you want to, say for example, you are using a 50 megahertz clock and you want to divide by 50,000. It's a lot easier to just specify it as an integer. Okay, so range 0 to 50,000, and then just specify that rather than trying to determine, okay, how many bits do I need for that? What would be the exact value of the counter when it is 50,000? So instead of having to do all that conversion and checking all of that, it might be easier to just work with integers sometimes. So it is not always the best idea to, you don't always have to use it. If you can use unsigned is beautiful, but then you might want to use integer instead. Okay, so in this video, what we've done is to define the same synchronous counter we did structurally. This time we defined it using a different method entirely. And this is a lot easier. This is faster. Your code, number of lines of code you had were a lot fewer, and a whole lot easier to define a counter this way. In the next video, we'll go a step further in our definition of synchronous counters, but this time we'll make use of case statements. Now, using the case structure will actually make our definition of the counter a little more complex than it is at present in this video. However, there is a reason why we might want to do that. So see you in the next video.